Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 7 of GCP Zero to Hero series, and in this episode, we will focus on three cloud computing characteristics. Number one is load balancing, number two is auto scaling, and number three is high availability. Even if you haven't heard of these terms before, don't worry, by the end of this video, you will master these concepts. Because I'm not only going to cover them theoretically, but you will also understand these concepts practically through a simple demonstration. I keep saying this after every video's introduction, but at least today's video deserves a special mention. After watching the video, please go through these device folders. So you can find the GitHub repository link in the description. Head to Day-7 folder, spend at least 30 minutes to revise the concepts that you have learned. This is a demo focused video. So I have created two MD files. One MD file explains how to implement the demo through the Google Cloud user interface. The same thing that I'm going to cover in the video. But if you want to go a step ahead, and if you want to try the same demonstration through the CLI, this MD file helps you with that. Perfect. Now, without wasting any time, let's start with the video. We'll start with understanding load balancing first. So what is a load balancer? Let's take a simple example to understand this better. Imagine Walmart is in its initial days. So, Walmart just started their e-commerce platform. So they decided to onboard GCP. So the management of Walmart decided that majority of our user base is in the US East region. So let's go for US East region on the Google Cloud platform. And they have also hired a cloud engineer. So they said the cloud engineer, take care of this entire setup. We want our application to be running on US East region. So the cloud engineer set up an account with GCP. Cloud engineer, choose US East as a region. Of course, first set up a VPC, and then within the VPC, created a virtual machine instance by enabling computing engine. And within the US East region, cloud engineer set up this virtual machine and install the application. Of course, the Walmart application. Then the cloud engineer tied the IP address of the virtual machine with DNS and shared that with the Walmart management. Now customers started accessing it. Customers are purchasing the product from Walmart. Everything is going well. Then Walmart said, okay, let's launch a sale to attract more people. So they have decided to go on a sale. But obviously, when Walmart goes on a sale or any company goes on a sale, the user traction increases. Let's say the current traction is 1,000 users per day. At least this number can go up to 2,000 users per day. So management said, okay, instead of 1,000 users, expect 2,000 users, or maybe even up to 3,000 users. Now the cloud engineer is worried because the existing virtual machine, let's say if it is of capacity 4 CPU, 4 GB RAM, and 100 GB storage. So the cloud engineer is worried that the existing virtual machine and the application can only handle up to 1,000 requests. So what the cloud engineer has decided is to spin up another virtual machine. So now there are two virtual machines, virtual machine 1, virtual machine 2, and in both of these virtual machines, the Walmart application is installed. Now the idea here is that cloud engineer thought, let me send 1,000 user requests here and 1,000 user requests here. But the big question is, who does this job? Because when users try to access the virtual machine, application within the virtual machine serves the request. If user sends request to this virtual machine, obviously this application serves the traffic, not this application. So here load balancer plays an important role. So what cloud engineers usually do is they front face these virtual machines with a load balancer, and they configure these instances within the load balancer. Typically, load balancers call them as target group. In GCP, we call it as backend services. So a load balancer is created in GCP. Now the cloud engineer sets up a load balancer. Within the load balancer, cloud engineer creates them as backend services, same virtual machines, but creates them as a group and adds that group to the load balancer. Now cloud engineer says management that, hey, share the load balancer user interface load IP address or share the load balancer DNS name. Now the management says that, okay, this is the URL. So customers try to access this URL. Now this load balancer takes care of sending 1,000 requests to this application and 1,000 requests to this application. But Abhishek, what if, I have two virtual machines, or cloud engineer has set up two virtual machines with one virtual machine, 6 CPU, 6 GB RAM, whereas other virtual machine with 4 CPU, 4 GB RAM. Now, instead of sending 1,000 requests to this virtual machine and 1,000 requests to this, can the load balancer send 1,200 requests here and 800 requests here? Yes, that is possible because load balancers today, they don't have a single algorithm, but they support multiple algorithms. This is the default algorithm to send requests evenly or to send requests in a round robin fashion. So this is called as a round robin algorithm. But load balancers also support ratio based, something like this. So here you can say the ratio is maybe 11:10, right? Or maybe 6:5 or 6:4. So you can say this ratio and load balancer forwards the request in the same ratio. Or you can also define that on the basis of geo, on the basis of weight. There are so many techniques that modern load balancers support. But end of the day, the role that load balancer plays is to send the request to multiple copies of the application. So the definition of load balancer is a component that helps to send the request to multiple copies of the application, depending upon the load balancer algorithm that is chosen. Okay. Now, if this is the load balancer, then what is high availability? And what is the purpose of high availability? High availability, shortly known as HA. Now, this is very important when you go for load balancing or when you set up an application that is user faced, or when you set up an application that has a lot of customers across the globe. Let me explain. So we'll continue the same example. Again, Walmart, right? So this time Walmart upload cloud engineer to create multiple instances, and the cloud engineer successfully set up this load balancer and two instances. But going back to the same example, if you remember, I said Walmart decided that the region has to be US East 1. Okay, or some specific region in the US. So within the same region and within the same availability zone. In region, there are multiple availability zones. Availability zones are data centers. We learned that in the previous episode. What cloud providers do within a single region, anywhere across the globe, they have multiple data centers which are called as availability zones. Now imagine cloud engineer created both of these virtual machines within the same availability zone. Right? Customer's problem is solved. Even during the sale, Walmart is able to handle the request. But what if, due to some reason, one of the data center face a network outage? Because end of the day, data center is also like your house or like your society. It also receives power. It also is maintained by someone. For some reason or for due to a natural calamity, the data center might face an outage. It's very common, a single data center. Now, in this case, because both of the virtual machines are in the same data center, the Walmart application is completely inaccessible, or the Walmart application is not available to the customers. Now, this problem can be solved using high availability. Now, what happens in the case of high availability? Cloud Engineer just change the way of setting up this virtual machines. So instead of setting both of these virtual machines in the same zone, so the Cloud Engineer creates the load balancer and says one of my virtual machine will be in US East 1F, a specific availability zone, and other application within the virtual machine will be maybe in the B availability zone. So this way, even if there is a natural calamity or outage in the availability zone, there is still another application that is alive and kicking and serves the request of the customers. In real world, this is a basic example. In real world, a load balancer can forward requests to multiple virtual machines in different availability zones across a region. Abhishek, can I also set up a load balancer that is region agnostic? That is, can I have one of my virtual machine in US East and other virtual machine somewhere in India? And can a load balancer serve that across the regions? Definitely yes. This is called as global load balancer. And the one that we are dealing with right now, or the one that I'm explaining here, is called as region-based load balancing. Or you can say by default, load balancer is capable of sending requests to copies in different availability zones of a region. But if you want, you can also create a load balancer, something like this, where the load balancer forwards the request to different regions across the globe. Okay, so this is the concept of high availability. Okay, understood. This is very important. Now, what exactly is the final concept? So we learned about load balancing, we learned about high availability, and I said in the introduction, we will also learn about autoscaling. So what is autoscaling? Autoscaling is a very critical component in the modern day applications. Imagine, Walmart goes on a sale, but Walmart is not sure about the size of the scale. In the previous example, I said, you know, Walmart goes on a sale and Walmart exactly knows that instead of 1,000 customers, cloud engineer should expect 2,000 customers or 2,000 users or 2,000 traffic on the website. But now what if Walmart is not exactly sure of the size? Now this can go up to 10,000 or this can remain as 1,000 itself. Or at peak, this can also go up to 1 lakh, right? In this case, how cloud engineer address this problem? Now, this can be pretty evident. Like if you take example of HBO, right? Imagine Game of Thrones is screening on the TV, right? A new episode of Game of Thrones is screened, right? In this case, how can HBO understand the size of the traffic? Even if you take cricket match as an example, imagine Virat Kohli walks in, right? Even in this case, Hotstar or Geo cannot actually predict the size of the traffic. In this case, cloud engineers go with autoscaling. So autoscaling is basically an add-on of high availability. So what cloud engineers do here? So, in the case of autoscaling, cloud engineers set up uh, virtual machines across different availability zones. That is what we learned through the load balancer. Now, when it comes to auto scaling, so instead of defining the number of virtual machines, cloud engineers create something called as instance group. So they set up an instance group. In the world of Google Cloud, we call it as managed instance group. So this managed instance group takes care of scaling up and scaling down of the virtual machines. Especially scaling up is important, right? So you can define or you can tell the auto scaling group, okay, initially set up 2 virtual machines. Okay, I'll not set up these virtual machines. I'll just give you the template how to set up the virtual machine, right? You will give the instance template to the managed instance group or auto scaling group, and you will tell this auto scaling group software, see, this is the kind of virtual machine that I need. Initially set up two virtual machines, but every time the CPU hits 80%, let's say if both of these virtual machines hit 80% of CPU limit, automatically add one more virtual machine. Again, if this hits 80%, automatically add one more virtual machine, right? One more. And if the CPU utilization goes by 20%, remove this virtual machine. Or if it goes by less by 10%, remove this virtual machine. Usually this is done by human, but because it cannot be done by human at that rapid scale, they cannot look at the metrics and they cannot immediately take the decision on it. It can be during orders, cloud engineer might not be available. So this can be done by a software called auto scaling or a component called auto scaling on cloud. In the world of GCP, we call it as managed instance group. Once again, very simple. I'll show you this during the demonstration as well. But step one, cloud engineer, create something called instance template. What is this instance template? This will just have the steps to create the virtual machine. What should be the OS of the virtual machine? What should be the size of the virtual machine? Right? A simple template is created like a document. And this document is shared to the MIG, Managed Instance Group. Managed Instance Group reads this template. Okay, initially I have to create two virtual machines. It creates the two virtual machines. And in this template or in the Managed Instance Group configuration, Cloud Engineer says, but along with two virtual machines that you have created, remember, if the CPU of the virtual machines exceed 80%, instantly spin up a new one. And if the CPU goes down by 10%, remove that virtual machine. So this is the automation that this component brings in, instead of a cloud engineer manually doing that effort. This is what companies like Hotstar, companies like HBO, companies like Netflix, whenever a new movie is released, this is what they do. The underlying concept is auto scaling. Now that you understood what is load balancing, what is high availability, and what is auto scaling, let's go ahead. Let's go to the GCP console and try these things practically. But one more time, all of these three components are complementing each other, right? Load balancing, high availability, and auto scaling are complementing features. Cloud engineers implement all of them when they are working with high user scale applications or high concurrent user applications. Perfect. So let's head to the GCP console. So I'll go to the GCP. Perfect. So this is a console. Let's first start with creating a project. Let me call this project as HA demo. So I'll just call it as high availability demo. You can go for any name. My bad. I have to create one. HA demo. Cool. Okay, so once this project is created, we'll first start with creating the instance template. As we learned here, step one is to create instance template. Perfect. So we are here. First, let's enable compute engine. We have done this in the previous episodes as well. So I might go a little fast. Compute engine. Perfect. Let's instead of creating instance. So this is the one that we used in the past, but now we will go with instance templates. Create instance template. Okay. So enable the API. This will take, I think, 30 seconds or little more than that. Great. So the template is ready to be set. Compute engine is enabled. I'll provide the name of this template. Let me call it HA template. Perfect. I'm not going with any tags or labels at this point. I'll scroll down. Location. Do you want to stick it to a region or global? I'll stick this to a region, the template, because I'm going to create all the instances within a region. Okay, within different availability zones, but within the same region. Okay, I'll keep it US Central one, no problem. I'll go with a very small sized instance, like with limited spec, so that I'll not be charged more. E2. So E2 is the lightweight one. Right now it says 25 US dollars, but I'm going to change this to E2 micro. This significantly comes down. And then I'm going to change the provisioning model from standard to spot. So I think this might come up to $3 to $4, right? I'm on my free tier and this is the best deal. Okay, perfect. Let's not change these things. It's perfectly fine. Container, boot, identity and access. Let's enable HTTP traffic. Okay. Advanced options, networking, disk. Okay. Networking is also fine. Disk, management. Now I'm just going through all the options to verify my template is right. I'll add the automation script or the startup script. So what exactly this does? When the instance spins up for you, if you want to install any packages, right? Or if you want to install Nginx, HTTPD, or maybe a Ubuntu or a Debian package, you can do it with the startup script. So this script executes as soon as your instance is booted, and this is executed as the root user. Now, in our case, what I'm going to do is I'm going to install Nginx web server and I'm going to set up a simple HTML page, right? So on these virtual machines, we will not install Walmart application, but what are we going to install? We will install Nginx web server with a simple HTML page. That will help us validate if the load balancing and high availability is working fine or not. A very simple application, right? Okay, so in the startup script, I will provide this script. You have this in the documentation on the GitHub repository. First, apt update, which will update the repositories, then install Nginx, and within var www.html, I have a simple index.html file. And this index.html file will be populated with this welcome message. Welcome to MIG demo, followed by name of the instance. So we can verify load balancing with this. You know, for the first instance, you might see something like welcome to MIG demo -1. For the second instance, welcome to MIG demo -2 -3. Whatever is the name of the instance. Perfect. I think we are all set. So we have everything in place. So I'll go ahead and create this. Remember, I have just created a template. I haven't created any instances. Usually we go to the VM instances and we create virtual machines directly. But this time we are playing with the managed instance group because I want the auto scaling group to maintain and manage my instances. Initially, I'll ask it to create 3, but if there is a load, I want it to increase that to 4, 5, 6 automatically. But Abhishek, how can we tell managed instance group to create virtual machines from this template? Just scroll down, you will find something called as instance groups. In the instance group, create instance group. So you have few sections here, right? Let's provide name of the instance group. I'm going with the default one, new managed instance group, stateless. You have to go with stateful if you're dealing with some databases. I'm dealing with simple web application, so I'll go with this. Okay, again, I'll say HA managed instance or demo managed instance. I'll leave the description. Instance template, select this template. Okay, so this is the HA template. Perfect. The one that we created. Now, as the next step, I'll just proceed with zones. So we have to define the zones because as we learned here, we want to set up each virtual machine in a different zone. So I will say not single zone, but multiple zones. Within the US East region, I want one instance in zone 1A, 1B, 1C. Okay. This is where we define what is the minimum number of instances, 3. And we can also define maximum number of instances so that your auto scaling will not create hundreds of instances. You can set up a maximum limit for it. So I'll say minimum is 3. When there is more load, make it 4, make it 5, but stop at 10. And this is what I was talking about in the theory part. So how will auto scaling group know when it has to create a new virtual machine, the fourth one or the fifth one? You can set up a parameter here. So you can say if CPU utilization is 60% or more, then go ahead and make it 4 or make it 5. Perfect. Or you can also schedule it. You can say at 3 a.m. In the or 3 p.m. in the evening, just increase the limit to 4 and then eventually during the end of the day, make it back to 3. Okay. I think we are good. I don't want to change any other thing. I just want to provide the name of the template, choose the region, create the number of instances, minimum and maximum, and also pick up the zone. Okay, I've done all of them. So I'll just go ahead and click on the create button. Perfect. Now the instance group is getting created. What does that mean? Once the instance group is created, that means you will see these virtual machines. And once they are created, let's make sure they are created in different zones. So we'll just verify that part. This will take up to 1 to 2 minutes because it has to create 3 instances. Perfect. So it says 3 instances are created. We can just go to the the instance group, see what are those 3 instances in the details. We will find the template that is used, where are the instance created, or we can just go to the VM instances and we will find all of these 3 instances. Okay, one is created in 1F, one is created in 1C, and one is created in 1B. So technically, our high availability concept is proved. Okay, so till now, we saw how instances can be created in a high availability setup. Perfect. Now, let's go ahead and create the load balancer. How do we create the load balancer? Very simple. So to create a load balancer, search for load balancing. Perfect. Load balancer. This is the one. Create a load balancer. There are different types of load balancers. Right now, just focus on the application load balancer. Network load balancer is used when you're dealing with DCP traffic or when you're dealing with traffic at layer 4. But because we are dealing with layer 7 traffic, that is the HTTP traffic, we will just go with the default load balancer or the application load balancer. Okay. Next, public facing load balancer or internal load balancer. In the concept of VPC, we learned when we want to forward the request from front end to back end, we can use the internal load balancer. But when we want external users to reach our load balancer, we will go with a public facing load balancer. Perfect. Now, what is the next thing? Best for global workloads, best for regional workloads. Both of them will work in this case because either you are going for a global load balancer or you are going for a regional load balancer. Global one can solve the problem of regional one. So it's up to you, whichever you want to go with. Let me select a regional load balancer. Create this load balancer. What does it say? You are about to create an application load balancer. Once again, if you want, you can also go with a global load balancer. Click on next. It has 2 options, global external load balancer or classic application load balancer. If you're going with this option, select classic application load balancer. Next, configure. Perfect. Now within the load balancer, as I told you, you have to configure target group or backend service. Front end, you don't have to make any configuration. If you want to provide, just provide a name, call it LB demo, load balancer demo. You can keep all these options, just the same thing, and go with the backend configuration. Backend services, create a backend service. Now, in this backend service, we will point the load balancer to our instance group that we have created. Very simple. Provide a name. I'll call it as backend instance group. Okay. I'll go with the instance group option. HTTP is the protocol. Perfect. This is the instance group that we created. HA managed instance group. If you don't find it here, that means you have done something wrong. Port numbers, we are dealing with port 80. So I'll just keep it as port 80. Utilization rate, let's keep all of them default and click on create. So it says health check is missing. Health check is very simple. For load balancer to understand, like let's say you have a load balancer and you have, I'll give you a simple example. Imagine this is the load balancer and this load balancer is pointing to three virtual machines, VM1, VM2, and VM3. For some reason, this VM has gone down. It can be because of the zone. It can be because of some configuration issue with this virtual machine, anything. This virtual machine has gone down. Now, load balancer should not forward the request to this, but now it should only forward the request to these two virtual machines. But how will load balancer understand even before forwarding the request? Like if a client sends a request and if load balancer forwards the request to this, then the client will face a bad experience. To avoid this, load balancer once in a while, every 5 seconds or every 10 seconds, default is 5 seconds, it will perform something called as a health check. So every 5 seconds, load balancer keeps checking if all the three instances are healthy. If it finds out that one of the instances is not healthy, it will immediately remove that instance from its algorithm and only forward the request to other two instances. So this is called as health check. Whenever you create a load balancer, you have to configure the health check. Again, this is not a rocket science. Only thing that you have to say is which port it has to perform the health check on. So I will say basic health check, right? Health check on HTTP traffic on port 80. You can keep the logs on so that you can understand if something goes wrong in the health check and click on the create button. That's it. Okay, now health check is being created. Backend service also being created. With both of them ready, let's go ahead and click on the create button. Review and finalize. So you can do one final review before you create the load balancer. Perfect. Name of the load balancer is HALB Autoscaling demo. Okay, create. Perfect. So now the load balancer is being created. Once the load balancer is created, let's see if we can verify our proof of concept. That is what we need. I mean, what should be the output? Now, once the load balancer is live, I will take a browser. I will try to access the load balancer URL. Load balancer will have a URL. I will access the URL from my browser and I will make multiple requests. Some of the requests should go to instance 1. Some of the requests should go to instance 2. And some of the requests should go to instance 3. We will verify this. But this is only possible if health check is successful, right? For any reason, if the health check fails, I will show you how to fix the health check. And then again, load balancer will forward the request to them. Okay. It's still being created. Typically takes a couple of minutes. So here I intentionally made this mistake. The backend service is down. That means load balancer is not able to communicate with the backend services. It says everything might be perfect, but I am not able to reach the backend services on port 80. We told the load balancer this is accessible on port 80, but load balancer says somehow I cannot access. Okay, we can also verify this if I go to instances. Okay, so I'll go to VM instances to quickly show you. I will take one of the instance. Okay, this is one of the instance. Let's copy its IP address. This is very interesting to know, like what is failing and why is it failing. IP address should be somewhere here of this instance. Let's see, let's try to find it. Or it should be here. Perfect. So it's here. I'll just copy it. From the browser, I will access on port 80. Now, by default, if you enter the instance IP address, by default, you are trying to connect to port 80. Okay, I'm not able to access. But if I click on this instance, okay, and if I connect to this instance through SSH, so I'm just connecting through the browser itself. If I connect through SSH, you will see that I am able to access the application through the curl request. So from the application, I'm able to access, but from the browser, I'm not able to access. Because I'm not able to access from the browser, same thing happens with the load balancer as well. See, I'll do curl localhost colon 80 and there is a response. Welcome to MIG demo, which we added as a startup script, followed by the name of the instance. Why is this happening? From the instance, I'm able to access, but from the browser, I'm not able to access. If you remember our previous lectures, I explained you something called as firewall. So you have to explicitly enable the firewall. Okay, firewall, just go to the firewall and you need to set up a simple firewall which enables access to port 80. Create firewall rule, not policy, my bad. Okay, create a firewall rule. Let's call this as allow HTTP. I'll leave the description. Logs, if you want, you can turn on to see if something goes wrong. You can look it in the cloud logs. Default, okay, it's fine. I mean, the default network, default VPC. Priority defines if it has to take priority on the other firewall rules that is set up. If you keep the number less, that means the priority is more. Ingress, allow the traffic inside. On which port do we want to allow? Right? So we want to allow a target tag. We'll create a target tag. We'll call it as HTTP server. So we should enable this tag on the instances. And here allow from all the IP addresses. So anyone who is trying to connect these instances from the world, or it can be load balancer as well, it should accept. Great. So I will say 0.0.0.0/0. This means everyone should be allowed access. If you only want the load balancer to access these instances, just provide the IP address of the instance here. That means the load balancer instance. Perfect. Now let's try to access the load balancer one more time. Let's get the load balancer IP. Okay, we made the firewall changes. Time to test. Load balancing. Okay. This is the load balancer and this is the IP address of the load balancer. Let's test it. I'll take a new browser, a new window. Great. So what does it say? Welcome to MIG demo. Look at this. It says QBW7. So request went to one instance. Let's refresh. It changed to QFZM. Let's refresh. It went to QBW7 again. HVM VFM. So what I'm trying to show you here, request is balanced between three different instances, right? As you keep refreshing, you will see request goes to different instances. Sometimes your browser might cache this information. So if you're not seeing this from the browser, do one thing, just use your terminal on your laptop and fire a curl request. So you can also do this through curl. For example, I'll take my terminal and show you curl followed by load balancer IP. One more time. Yeah, so it kept changing. So from QFZM, it changed here to HVFM, and this time it changed to QBW7. So this is one instance, this is other instance, and this is other instance. So this way you can understand how load balancing works. So we learned about load balancing, we learned about high availability because instances are created in different zones. Of course, we cannot delete a data center, but at least we can understand that from that console, how instance group creates the instances in different availability zones. Finally, when it comes to high availability, if you can increase the load, because this is a sample application, like uh, the CPU utilization cannot go up to 60 or 80%. So that's why instance group will not spin up a new instance. But if you go for a complex application and if you keep sending multiple requests again and again, you will see the instance group will create a new virtual machine. But in this case, because it's a sample application, the instance group will stick to three applications only or three instances only. Perfect. So this is about today's video. One more time, if you are stuck at any point, don't worry. The notes is very detailed. Just follow the notes. You can take the UI approach to finish the demonstration, or you can take the CLI approach to finish the demonstration. Let's start with the UI if you are a beginner. Thank you so much for watching today's video. I hope you enjoyed it. See you all in the next one. Take care, everyone. Bye bye.